To determine the wavelength of the wave, we can measure the distance of the neighboring peaks. Let's say this point here and this point here. And then in the questions, the position of this peak is given as 0.15, and then the other one is 0.55. So the distance of these two peaks is simply given by 0.55 minus 0.15. So is lambda, which is the wavelength, is equals to 0.4 meter. Alright, so and now we need to describe the movement of B for one complete cycle starting from time t equals to 0. So the waveform that I have shown here is the waveform that we see at time t equals to 0. So, and we know that the profile is actually moving in this direction, and this is just a snapshot at a particular time. So when t is larger than 0, then the entire profile is going to move into the right hand side of the diagram. So what happens is that point B is going to move along the curve down and then up again. So it can be illustrated by this. So as the wave profile move to a new position, then what happened to point B is that it's going to move to a new location. So the movement of the B is such that B will first move downwards to the minimum point and then go up again, passing through the 0 point up until the maximum, and then come back down to the position where t is equals to 0. On figure 4.1, which is this figure here, mark a point on the rope that has the same vertical speed as point A, but which move in the opposite direction to A. Label this point as point C. So, and we know that point A is the middle point of this curve, the oscillation curve, and so it says that the point which has the same vertical speed. So this point here, this point here, and this point here, they all have the same vertical speed as point A. But we need to find the one which move in the opposite direction to A. So, and since we know that it's moving in this direction, the curve is moving in this direction. So point A is actually at the moment moving upwards. Yeah, because at the new location, I mean when time is larger than 0, point is going to move upwards first. So definitely the velocity is pointing up. And then let's look at the other 3 points. So for this point here, it is moving downwards. So it fulfills the condition that the question wants us to find. And then for this point here is actually in the same phase as point A, so it's also moving up. So this is not the point that we want. And then this point here is actually in phase with this point here, so it's also moving downwards as the wave propagating into the right hand side. So in fact, for this question here, we have to answer. We can either name this point C or this point here. Alright. So the horizontal speed of the wave is given by v is equals to 2 meter per second. So then calculate the distance traveled by the wave in 0.1 seconds. So this is easy enough. Displacement is equals to v multiplied by t, and t is equals to 0.1. So the distance is simply given by 0.2 meter. Alright. So on figure 4.1, draw the new position of the wave for time equals to t. For time t equals to 0.1 second. So the new position Let's make it a new color. Would be something like this. Because the entire waveform is already propagated by 0.2 meter. So point is going to be the new peak. Let's mark the important position first, and then point C is going to move down all the way down to this point here. Yep, and then as for the other point, yeah, the new peak position is here, and then this would be the zero position again. Then this is also another zero position. Yeah, and yeah, let's draw the curve. I guess this is the new C position, so it will be like this. Yeah, as we can see, the curve has already propagated towards the right hand side at time t equals to 0.1 second. Yeah, this will be a new curve. That's all.